Let's look at this question, which has a slightly different format from the usual calorimetry questions. Usually for calorimetry, you are given the temperature change and you are asked to find the enthalpy change. But for this question, you are given the enthalpy change and you are asked to find the temperature change. In this question, we are given a reaction between nitric acid and barium hydroxide. So let's first write out the equation for this chemical reaction. This should be the balance equation. However, if we look at the question, we see that the enthalpy change given is when 1 mole of nitric acid reacts with half mole of barium hydroxide. So it's actually referring to half of this reaction that we wrote out here. So let's times everything by half. And the enthalpy change for this reaction is negative 56.2 kilojoules per mole. Since we know enthalpy change, we can find the heat of the reaction by taking enthalpy change times the number of moles. But first of all, we don't know whether there's any limiting reactant in this reaction. So first we have to find out. So let's find the number of moles of each reactant. From the chemical equation, we see that the stoichiometric ratio of nitric acid to barium hydroxide is 2:1. And we also see that the nitric acid and barium hydroxide present is in a 2:1 ratio. So basically, there is no limiting reactant. So to find the heat of the reaction, we can either use the moles of nitric acid or the moles of barium hydroxide because there's no limiting reactant. Let's use the moles of nitric acid because this will be a nicer number, since this negative 56.2 kilojoules per mole refers to per mole of nitric acid. So to find the heat of reaction, you will take the enthalpy change times number of moles of nitric acid. And you will get negative 29.59 kilojoules. Now this is the heat change for the reaction. For the heat change of the solution, so Q solution, basically it is equals to the negative heat change of the reaction, because we assume that all of the heat that was given out by the reaction will be absorbed by the solution. So heat of the solution would be 29.59 kilojoules. Now the final step is to find the final temperature of the solution. So in this case, we are given specific heat capacity of water. We are given the volume of the solutions and the density. So from volume and density, we can find the mass of the solutions. So add up the volumes and times density. And you will get a mass of 1,620 grams. Let's use the equation Q equals to mc delta T. And let's substitute the values in. Notice that earlier on we found the heat in terms of kilojoules, whereas the specific heat capacity is given in joules. So we have to standardize the units first. Let's convert the heat to joules. So to convert to joules, you have to times 1000. Temperature change would be final temperature minus initial temperature. So with that, you can calculate the final temperature. And we will get the answer 22.83 degrees Celsius. So if you just double check, this is consistent with your initial enthalpy change. Enthalpy change has a negative value, which means it was an exothermic reaction. So since the reaction gave out heat, your final temperature would be greater than your initial temperature.